Well, again, this course is Introduction to Engineering with me, Dr. Raf Teloni. You guys, some of you are first year in engineering and you would love to know more. What is engineering about? Is engineering a good thing for you? Do you fit in that field? Even out of curiosity to know what does engineering means, where it came from, and what do engineers do on the daily basis. So we will try to cover all those topics in this course. Where did engineering come from? Can anybody tell me the word engineering or the concept of engineering, where it came from? What's your thoughts? Anybody have thoughts on that? Well, in the past, speak up if you have anything to say. So, in the past, we had physics and we had math since forever, since the science being created and developed as something to be taught. We have physics and we have mathematics. Then, at times, as the humanity knowledge advances, they start to show up some applications. Like, let's say you have a river, then you have a kind of windmill style on the river that will. They said, hey, we can grind our, let's say, beans or our wheat using the force of the river. So they put a kind of a gear on the river. I believe you can imagine what I'm talking about. Then that would move with the flow, and that would transfer the power somewhere else to rotate it and give a certain force to smash the seeds or the wheat and so on. So now we start to have those kind of things, like how big is the wheel to put it in the river, um, how long should be the shaft to go to grind the seeds and so on. All of these need calculations. They used to use mathematics. Then now you are doing a physical application. Like when you are using the force of the river flow to grind your seeds, now you are implying mathematics by doing calculations, but in the same time, you are doing physical application. So combining physics and mathematics provides engineering. Like when you combine the application with the theory, that is what is engineering is about. What does the word engineer mean? Where it came from? Anybody know? The term engineering, not engineer, derived from the word engineer itself. Engineer word was used first at the year of 1390, where the engineer or was called as the one who operate the engine. So engineer from the word engine basically, and by that time means the operator who construct the engine or who build the engine. That's where the word engineer came from. So when somebody asks you, this is why there is a bias in engineering to mechanical engineering, because basically the ones who created the engines is mainly a big effort from mechanical and collaboration with electrical and industry and other stuff. But you have civil engineering, mechanical engineering. Those are kind of one of the oldest, one of the main. That's controversial topic. We are not biased by any of these. All engineering is an important subject, but mechanical engineering is the word where engineering came from. Now, as engineering profession, we will talk more about what would you do as an engineer while having an engineering profession in the industry. For this chapter, our objectives is to understand the role of engineering in the world and how to operate meaningful engineering career and how to prepare for it as well. Then the role of the engineer itself in the engineering workplace. When you are in a company building a vehicle or managing a production line, or let's say you are in one of Amazon production factories taking care of all the shipments of the people, then there's a lot of engineers there. What do they do? What's their responsibilities? And what are their qualities or ethics? Then we expect you to know the responsibility and roles of the common engineering fields. Now, what we can learn about engineers, if you ask me what does engineers do, engineers basically are problem solvers. If there is a certain problem in a certain application, then engineers will come in and solve it. Then if the community or the humanity is experiencing a certain problem, let's say in the past they have a problem, they are moving on animals from point A to point B, but animals are too slow, animals get tired, and uh, they affect by weather and so on. So engineers need a way of transportation, so they came up with automobiles or with vehicles in its simplest form. So they solve the problem of going from A to B in a non-reliable way, which is animals or walking and so on. Then successful engineers would possess good communication skills. As an engineer, you would be able to present yourself properly. That's very important for you in the interviews. Even when you 3, 4 years later, you will be interviewing for jobs. Now, sometimes, honestly, it doesn't matter how much do you know about a certain field that you're applying for. To be able to sell yourself, to be able to market yourself, communication skills are important. Uh, the problem, in engineering, there's many engineers, they get dedicated into science and learning about stuff. It's just kind of a geeky style, but that will drag them away from being a good communicators. So I would advise you ahead of time, as an engineer, try to communicate well. Communicating doesn't mean how you wear, doesn't mean how you speak, doesn't mean how you think. It means how you deliver your message, how you give an image for somebody in front of you about yourself and your skill knowledge. Then you are, as engineer, expected to be a team player. There's no engineering application happened by one person. Maybe in the past, like in the initial steps, but maybe you heard the story about Henry Ford building the first vehicle um, in his kitchen or garage or something. But I don't believe so. He did it by himself. There is always people around. At least he go somewhere, take advice, get a hand to help him in something. Then he will continue alone. But as an engineer, you are a team player. That's added to the communication skills. You need to know how to communicate as working with people. Like today, if you go to General Motors, when people are working on a, let's say, Silverado pickup, there's people working on the chassis design. There's people working on the engine design, engine development, engine testing. There's people working on transmission, people working on the aesthetics and how it looks on the interiors. Every aspect of those is being handled by a certain engineering team. This team could be between 10 to 100 to 1,000 engineers. So they need to communicate properly and efficiently to each other, either through electronic means or through person to person or in person meetings. Then engineers have a good grasp of fundamental physical laws and mathematics. Of course, as an engineer, you're being expected to be, I don't want to say genius in math, but good to very good in math and physics. You are able to solve any physical problem on paper so that when you are in the field, you're able to connect between theory and application. And hopefully, we can help you as well connecting between those as moving forward with this course and other courses to connect between theory and applications. So one of the problems in the, some educators would fall into it. They focus more on the theory and they forget to connect the theory with the application. Even myself, back in time as a student, I can put myself in your shoes and I would ask, okay, you gave me this lengthy equation that you drill my brain about it for a week. Then where do I need to use it? Where does it happen? Who's using it today? So that kind of thing we'll try whenever possible. Sometimes there's a little tiny thing, it is used somewhere, but it's hard to link it right away. But there's, in many cases, it is easy to link the theory and application. And let's see how much room we have and how much opportunity we have to collaborate. Maybe we can go a visit somewhere. We can let you meet some of the successful engineers and talk to them, and even maybe in through a Zoom meeting or something, and talk to them and see what do you think about it. Then engineers apply physical, chemical laws, mathematics to do design, development, test, and be able to supervise the manufacturing of million products and services around the world. And engineers are expected as well to keep in mind important factors like sustainability, efficiency, cost, reliability, and safety while they are designing the product. Like when you're designing, let's go back to the car since we used as example. So you design a car, you don't just design a car that's just running. You need to make sure the car doesn't catch fire. You need to make sure when you have an accident, when a driver hit the wall, the chassis of the vehicle doesn't crunch on the driver. So the strength of the chassis can be able to hold the impact and be able to let the drivers and passengers survive and so on. Engineering work is all around us, of course. If you want me to list for you engineering products, then you can see we have cars and vehicles in general. Could be train, could be car, could be airplane, anything having a driver and a passenger is an engineering product. Then we have as well, no need to mention home appliances, your refrigerator, your microwave, your PC, your speakers, your dishwasher. All of these are being designed and applied through certain engineer, just like you. Then, of course, the phones in your hand are being designed by engineers. Could be mechanical, could be industrial, could be electrical. All of those combined together to create nice products for you. Spaceships, of course, is a big factor of an engineering products and how much engineering can lead us. We can leave the Earth atmosphere just by engineering. We can even simulate and imagine what's going to happen outside of our atmosphere in the space that we never met or we never lived in, or on Mars and so on. So you guys are the next generation who will be uh, the outer space generation of engineers. I would say, like, you would focus more on products that can work on Earth versus working on other planets. So I believe some of you would have the opportunity to be on such kind of teams. So I want to pause here a little bit, and I want you to look around you and tell me what devices around you think are being done through engineering, or a certain engineer designed and applied it.
A computer.
Okay. Who else?
The projector screen.
Great. Can we consider the table being an engineering product, or done by engineer, or it could be something else?
Probably not.
I would say tables, you know, it's there's a craftsmanship that's something before engineering, so it's good to mention that. Before engineering, there was people who are handy, who put things together on a personal level, or two, three people working together. That's what's known as craftsmanship. So people are doing things by hand. They do it at home. They have their own machines, or they could maybe manipulate the wood, manipulate the metal to do certain things. Uh, I would say any object that is having mathematical and uh, physical properties could be an engineering product. Now, is it a simple, basic engineering product, or is it sophisticated? That is the difference. Yeah, table, as it is right now, it's obvious. It's kind of a rectangle. It has sharp angles, 90 degrees on each side. It has legs. It's been considered, like, when they designed the table, they looked at how much weight will be sitting on that table. So you can find the office table or the office desk will be heavier than the regular table, like let's say the food table, because the office desk will hold more stuff. So that means he could fail, and maybe the stands, the leg stands of it will be bigger, and so on. So we could say anything you put thought into it and you use mathematics or physics or a combination could be considered as an engineering product, even though it could be a simple, silly product. What else? Who else have in mind something around you in the room being done by engineers?
The light switch.
Right? What kind of engineer you think he designed it? Is that a mechanical engineer? Is it electrical engineer? Is it electronics engineer? Is it industrial engineer? What do you think? Who's let's say worked the most on it?
Electrical.
All right. Who else have any object around him that he thinks it is an engineering product? All right, I think that's good. We will keep going in the presentation. Now, I would say the world need you. Why the world need you? The world need you as an engineer because, as we mentioned, engineers are problem solvers. Engineers have unique abilities in mathematics and physics to combine those together, to think creatively, to be able to create new products to the world. There is a phenomena that some engineers design a product, and let's say an invention or a new cool product, that probably you will go through it as moving forward in your career, then you fall in love with this product because you made it, because you made effort on it. It came out of your mind, so it has a special value for you. Regardless of that, there is some products that the market needs, like let's say the hand sanitizers. When those chemical engineers designed the hand sanitizers, they designed them to reduce the amount of bacteria on your hands or on the parts that are in contact with a non-clean surface, let's say. So of course you say recently we need sanitizers very well, but since forever sanitizers are important products, it could be silly for some people, like, no, I can't consider that a product. Some people consider it a very important product. So you come in to solve problems. Sometimes you are not willing to solve problems. You're not interested in sanitizers or making a chemical formula for sanitizer. But as engineer, you are required to try to solve a problem that the world have today. In the same time, you think about it business-wise. Like, okay, now if I do this product, I'm going to sell this amount of products. So I'm going to succeed and grow more and so on. So the world, of course, world population is increasing as years move forward. Then the environmental scientists are having their concerns. And as you know, the Earth has finite resources. So there is more being expected from engineers. So the future engineers, we expect you to give us good services that will increase our standard of living. So we can live more comfier, we can live happier, we can have more time on our own, we can live safer, and so on. So one of the factors that we care about in engineering and the world is expecting you to have some focus on is advancing the healthcare. And in the same time, that could be through addressing serious environmental and sustainability concerns. So in the 20th century, we had approximately 6 billion of us inhabiting the Earth. And this number is just growing more and more, as you can see here. So we said the population of the world is growing year by year because, you know, the healthcare is getting better. There's more products to make your life easier. You're not making effort as much as you used to make. So if you look here at this graph, did anybody of you never saw a graph before? Everybody is comfortable looking at this graph? I'm gonna go through it, but like we can elaborate more in case this is something you never see before. Well, the thing is you have y-axis and x-axis. I know for some people like what you're doing, we already know that, but like let's confirm. On the x-axis, we have the years. So we have from the year 1950, 1960, all the way to 2020, 2050, and so on. So that's the year. Then you have the population in billions. So this one means 1 billion, 2 billions, 3 billions, 4 billions, and so on. So this line is representing for you what is going on with those numbers. Wherever you stop, you can go down to the year, you know, in year 1970, how much the population was, let's say 3.5 billion. So what you can read from this graph, the population is increasing more and more. Before there was wars, there was death, there was the, breakthrough in diseases. They kill people and they keep the percentage low. Like the population is not growing very fast. These days we have less wars, of course, and we have more healthcare and people are living longer. So there's more people living on Earth, sometimes more than what the Earth resources can handle. Here, another figure, you can see the latest estimate of the elderly population growth. So you can see the year over here, and you can see the population per thousand over here. So in the year 1990, we had elderly people, means anybody over 65 years old. We had only in 1990 37,000 people, while in 2050 it is projected or expected to be 834,000 people with the age above 65 years old. That means these people, maybe today, there's not much attraction into products for comfort or let's say self-driving vehicle. While in 2050, there will be more people needing self-driving vehicle because their vision is getting low, their health is getting low, they're not qualified anymore to drive, so they will be going towards using a vehicle that drive itself. Let's say, as an example, there's many examples. So there is more products, more projects, more ideas come from engineers to make the life of older people easier, and they'll be able to maintain a good lifestyle as moving forward. What do engineers do? Basically, the engineers, they apply physical and chemical laws and principles, as we mentioned, and mathematics to design millions of products and services to use in our everyday life. They do as well consider important factors, as we mentioned. They care about making things as low cost as possible and the efficiency of the product as high as possible, even of processes. So engineers, they don't look only into products. They look into processes. As we mentioned, if you go to Amazon warehouse where they have all these boxes running around on the conveyor belt, you need to be efficient. You need to bring the right box in the right time so that you can get out of the factory more boxes in less time. That's efficiency. It could be efficiency in terms of, let's say, your vehicle, your car. How good is your car? How much is the gas consumption? That's kind of efficiency. Sometimes efficiency is related to reliability and durability, like how many years can this vehicle survive with me without breaking down, and so on. Engineers as well, they are always searching for ways to improve existing products. Some engineers, they invent and create products out of nowhere. Some engineers, they and that's a big factor, like many of engineers, they work on developing existing products. Like today, let's say you have a vending machine and you don't like the way it will deliver the product to you. Maybe you can design another machine in another way and form and be able to serve humanity better. Engineers as well perform tests and make certain that the products that they are making can handle various loads and conditions. If you take a visit today to Toyota, then you will find in the testing facility, when they develop an engine, the engine have, firstly, it will go through assembly line. He will go from the first bolt all the way combined together, like in a running state. After that, he will go through an assembly line where the engine is being tested. He can withstand all the torques, all the spinning speed, the RPMs, like rounds per minute, similar to what you do while you're having your Toyota vehicle in your parking lot. Let's say, what if after we put the engine, he's qualified, we put it in the vehicle, now the vehicle is being tested through testing engineers as well, and do the maximum to it. They will go high altitudes. Let's say they go to Colorado, Arizona, and so on. They go in hot areas like Nevada. They would go in cold areas like Michigan in the winter, and they try to see what would the vehicle perform. Would it run in the morning? Would it be low in battery? Would it have any challenges? Can it survive? And all of those things. That's in terms of one product. Same thing if you have a hammer. When you have a hammer from Home Depot or somewhere else, this hammer is being crafted in a certain way mechanically. Then they want to make sure this hammer can apply a certain force on another object without breaking down or without bending, and so on. So engineers are designing, creating, building stuff from nowhere, sometimes advancing the current already existing products, and they test those, make sure they can serve you well, while in the same time taking care of the cost, efficiency, and reliability. Now, if you want to look at the engineer's work, of course, engineers do design. That's the main things engineers do. But there's other engineers who work as sales representatives. So those are trying to sell certain products. Why we need sales? Why didn't take somebody with a business degree? The thing is, some products are too much into engineering. It has a lot of engineering details. You can't bring somebody from the business school and tell him, try to sell for me, let's say, this airplane, or try to sell for me this, I don't know, generator or something. So the engineers, they know details, they understand the language of engineering, so they can market the product better in case they decided to be in sales. I know the engineers who are doing very well in communication, they could like sales. Many engineers who are like geek style, if you will, who are really deep into science, would prefer to be in a company designing, doing something, changing the world in a more hands-on way. So that's one thing why we have sales engineers. Then there's many engineers as well. Their engineering background could help them to discuss the technical information with the customers. And of course, you have design engineers, you have testing engineers, you have industrial engineers and the manufacturing engineers, and so on. So honestly, in engineering, there's many ways. If you like to be a salesman or a sales engineer with enjoying the respect of engineering degree, but in the same time, you're still in sales and collaborate with people, go with meetings and go with interviews and so on. You can do that, or you can design products and inventions to the world and change the world to make it a better place. Now, the engineer qualities. What do you think, regardless of this presentation, what do you think the engineer personality should be? Like, what things he should gain? Like, when you meet an engineer, let's say somebody came out of Ford, and you say, hi, he said, I work for Ford as electrical or mechanical or a manufacturing engineer. While you look at him, before you know his personality, what would you expect out of him? Qualities means like personality, the best personality sides. Anybody have suggestion? What would you expect from the engineer to be in terms of personality? Should he be fun? Should he be having a good knowledge? Should he be talkative? Should he be whatever? Yeah, go ahead. You know, because we said engineers are problem solvers, so he should be smart to solve problems while others can't. Secondly, he need to be knowledgeable. So he need to have a good knowledge about the fundamental principles of engineering, which he use for solving different problems that he meet daily. Engineer is expected to be creative. Of course, you know, you don't need to have them all, but you have some qualities that make you different. That's why there's some engineers working in a certain place, some engineers doing a certain thing because of their qualities. Based on the qualities, they've been naturally selected within the marketplace to fit in their place or to fit in the best position that is suiting their qualities. They're creative, they do analytics, and they are details oriented and creative. And of course, though, those engineers are learners, so there's always no day that is the final day you're learning something. You're always learning because there's always new softwares, there's always new products, there's always new inventions, either to it's showing up in the market by other engineers. You got to keep up with it and keep up with these applications so that you are always learning to do your job better. And he's a communicator, so as we said, communication is important. Not every engineer master that. Honestly, one of the weakest points in engineers is communication. So if you do your communication to be the best, then for sure you're a premium engineer that everybody would love to have you in their team. Then you are a team member, as we mentioned before. You know how to work with other teams. You know how to keep professionalism between you and the other teams. There's always, of course, arguments. There's always, you need the project to go this way, the other one or the leader or whoever need the project to go that way because you think it's better. But you need to go overcome through those bumps in, you know, in a professional way, while the main target is to lead the company to success. For jobs, if you are concerning about jobs, engineers are some of the highest salaried jobs among those holding bachelor degree. So when you finish your bachelor degree as an engineer, of course it varies based on what type of engineering you have, but we can see here in 2008, engineers are holding 1.6 million jobs out of the job market. So you can see here in this table, engineering employments by discipline. Of course, you can, this is an older statistic to be honest, but still applying today because today just the numbers are doubled, but it's the same trends. So in civil, there is 17% of the market is working as civil engineers, and there is 15.2% working as mechanical engineers, and 13.7% as industrial, then electrical, electronics, computer hardware, aerospace, and so on, so on, so. So you can, you know, if you look today in Statistica, I believe this is a website, you know, he give you recent statistics. Then you can see the trend. What is the best engineering topic I should go for so that I can find jobs easily? But I can tell you, as long as there is real estate, then civil still applies, and architecture engineering as well. As long as there is machines, there is some spinning parts here and there. Mechanical, industrial, and electrical will always have a place to work. Electronics, as long as there is smart devices, and they as well, you know, each machine, even the car, need electronics engineer, need mechanical and electrical. So those top 5 honestly is still the top 5. While now surprised everybody, computer science and computer engineering start to be a trend lately because of all those applications blooming and so on. The average salary for engineers, again, this is from 2009, not reflecting today. They say aerospace is 56,000 a year. Agricultural is 54. Bioengineering is 54. Chemical is 64. Civil 52. Computer is 61. And electrical is 60. Industrial is 58. Mechanical 58, and so on. I would say don't be bought into those numbers. First, they are outdated. I tried, to be honest, to get you more recent numbers, but I thought I would be biased, so I keep it as what the textbook is suggesting here. But the numbers are being pumped a little bit, so instead of talking most of them around 50s here, now you are seeing most of them around 70s, based on the inflation and based on other stuff, you know. Okay, we have 5 minutes here, so I think we're gonna conclude. I have for you some scientific reading. I thought we will have a chance to go through it together and try to let you go through these websites and give me your thoughts on it. But I think I'm gonna delay it until next week. I don't want to go. I don't want to get you busy, guys, from the first lecture.